Anita Sama, Vishwarapa Vishwa. At 10 p.m. I'll take the integration class. But at 9 p.m. I'll take the convergence class for B.Sc students. Okay. Anita Sama, you are plus 2 or plus 3? Anvita, now the convergence is for B.Sc students. Now then don't attend the class because you are class 12 students. This is not in your syllabus. Okay. This is special for B.Sc students, B.Sc and M.Sc. Krishna Chandra Sahu. Subhalakshmi Sahu. Now 13 students are watching and only like button you have pressed only 9 students. Is not it? No one is giving comments. Very good. Alok Pani. Yes, this is for specially for PG entrance. Okay. That is why I am taking Asutosh Machi. Pratiksha Priyadarshini Pani. Is there any network problem? Hello? Surrender, so yes. This is in your IIT syllabus, IIT exam syllabus. Only for PG entrance I am taking this class. Okay. Let me trace out. The box universe. Whether the weather is perfect or not. Hello. Let me just, I am fine. What type of names you are giving? Deepak's universe, Sachin gaming. Okay, after 2 or 3 minutes, I'll take the class. Okay. Mm, Since the weather is not perfect, so And in my last class I have told you about ratio test. Clear? And today another test I will tell you. Okay? Lateral peso. For Odisha PG entrance, everything, the first year, second year, third year syllabus, all are included. And basically the first year and second year syllabus are included. Okay, so let's start. Good evening everybody, and today I am going to tell you about real analysis and how to test the convergence of a sequence. Okay, Lateral peso told me that what is the syllabus? Your syllabus is mainly first year and second year. And in third year, your multivariate calculus, that means the limit continuity, change of variable, composite function, partial derivative, homogeneous functions, and maxima minima, your Jacobins, and vector calculus, and multiple integrals. Okay, and that paper is very, very important. And from probability you will also face some questions, and it will be direct questions. Okay, and from complex analysis also you will face. See here, from third year, if you want you can write it down. Complex analysis and multivariate calculus and your probability. These three papers are very important from third year, and other papers you should cover from first year and second year. All the papers you should cover. And from model algebra and linear algebra, you should remember the statements basically, not the proofs, and some conditions. Okay. And from area length volume, that is from paper 1. And differential equation is also very important. Okay, and since it will contain subtype questions, so you can eliminate partial differential equation. Okay. And other papers are from final year only complex analysis, probability, and multivariate calculus you should cover. Okay, so see here, P test. Your P test is summation n is equal to 1 to infinity 1 by n to the power p. Summation n is equal to 1 to infinity 1 by n to the power p is convergent if p is greater than 1 and divergent if p is less than or equal to 1. If you write here alpha, then it will become alpha test. So since this is P, I am writing P test. If you write here alpha, then it will become alpha test. Okay. And limit form of comparison test. Actually this test is very important. Limit form of comparison test. Here summation n and summation bn. You may say, I want to tell you, if summation and bn and summation n are any two series, I am not telling you positive term series. Okay, and limit n tends to infinity, an by bn mod. See here, if you take positive term series, then it is not necessary to put the mod. You should not take the mod. But I am taking only any series. I am not considering the positive term series. If we take the positive term series, then there will be no modulus. Okay. So let it be equal to L. What is L? A positive finite value. Then summation n and summation bn will behave alike. And what is the meaning of behave alike? That means both will be convergent or both will be divergent. Clear? So according to bn, if bn is convergent, then A will be convergent. If bn is divergent, then A will be divergent. And here in your question, an will be given, and you have to choose bn. So how to choose bn, I will tell you. Clear? So after choosing bn, and find the limit intends to be n by bn modulus, and let it be n. And if n is a positive finite value, that means it must be greater than 0 and less than infinity. This L so belongs to 0 infinity. Clear? Then both summation n and summation bn will behave alike. That means both will be convergent or both will be divergent. The question is that how to choose bn. That part is very important. And basically it is applicable to algebraic functions. Algebraic function means it is actually rational function, p by q form, and p is an algebraic or polynomial, and q is also an algebraic function. And the degree of numerator must be less than the degree of denominator. The degree of numerator must be less than degree of denominator. So in that case, you can apply this test. Clear? See here, I am giving some examples, then only you can find out. First of all, I am giving a simple example. An is equal to n square plus n plus 1 divided by n to the 4 plus 1. See here, n square plus n plus 1 divided by n to the 4 plus 1. Here, the degree of numerator is 2 and the degree of denominator is 4. So I have told you, if the degree of numerator is less than that of the denominator, then you can apply this method. And now, how to take bn? Let bn is equal to 1 by n square. So, how to choose? What is the degree of numerator? 2, and the degree of denominator is 4. So 4 minus 2 is 2. So 1 by n square. 1 by this much. N to the this power. Here the power is 4. Here the degree is 4. Here the degree is 2. So 4 minus 2 is 2. So n to the power 2. It will be 1 by n to the power 2. So then, therefore, limit n tends to infinity, an by bn mod is equal to, directly let us write first of all, an. Here an is this one, n square plus n plus 1 divided by n to the 4 plus 1, and 1 by n square, and n square will go to the numerator. Clear? So after multiplying it to the n to the 4 plus n cube plus n square divided by n to the 4 plus 1. And I have told you, if the degree of numerator and denominator are same, then the answer will be the highest power of the numerator, coefficient of the highest power of numerator divided by coefficient of highest power of denominator. So 1 by 1 is equal to 1, which is a finite value, finite positive value. You should write like this, finite positive value. So now, what is Bn? Whether it is convergent or divergent, apply the p test. Here p is 2, and I have told you it is convergent if p is greater than 1. Here 2 is greater than 1. Clear? So by p test, summation Bn is convergent. Hence, by limit form of comparison test, summation n is convergent. Here you may write, hence summation n and summation bn will behave alike. Why? Because it is a finite positive value. If limit intends to be n by bn current unity or modulus is a finite positive value, then both n and bn will behave alike. And since by p test summation bn is convergent, so automatically by limit form comparison test summation a is also convergent because they will behave alike. If summation bn is convergent, then summation n will be convergent. If summation will be divergent, then summation n will be divergent. Clear? Now let us see another example. So slightly complicated example I am going to tell you. Summation n is equal to 1 to infinity n plus 5 divided by n into n plus 1 into n plus 2 root of. Clear? See here, this is an. Here an is equal to n plus 5 divided by n into n plus 1 into root over of n plus 2. So how to type bn? See, if the degree of denominator is 1 plus 1 plus half, 1 plus 1 plus half, that is 5 by 2. And here the degree of numerator is 1. So 5 by 2 minus 1, it is 3 by 2. So 1 by n to the power 3 by 2. I have told you the degree of denominator is half plus 1 plus 1. It is 5 by 2. And the degree of numerator is 1. So 5 by 2 minus 1, it is 3 by 2. So 1 by n to the power 3 by 2. Therefore, limit n tends to infinity, an by bn is equal to limit n tends to infinity, it is n plus 5, it will go to the numerator into the 3 by 2 divided by n into n plus 1 into n plus 2 root over. Then it will multiply, it will be into the 5 by 2, this will go into the 5 by 2 which is equal to 1. So which is a finite positive value. Therefore, summation n and summation bn will behave alike. Now, since summation bn is here n to the power 3 by 2, 3 by 2 is greater than, that is 1.5, 1.5 means greater than 1, and therefore it is convergent. Summation bn is convergent by t test. Summation n is convergent by limit form of comparison test. Clear? So this is how to choose bn. Clear? See another question. Summation sin 1 by n. Here an is equal to sin of 1 by n, and already you know limit n tends to infinity divided by 1 by n is equal to 1. Limit n tends to sin 1 by n divided by 1 by n is equal to 1. So let bn is equal to 1 by n. Therefore, limit n tends to infinity, n by bn mod is equal to limit n tends to infinity, it is sin of 1 by n divided by 1 by n is equal to 1, which is a finite positive value. Therefore, I am not writing, you can write it. Therefore, summation n and summation bn will behave alike. Now, since summation bn, see here 1 by n, that means t is equal to 1, and if t is equal to 1, then it is said to be divergent. Summation bn is divergent by t test. Implies summation n is divergent by limit form of comparison test. Okay. See here, another question. I am giving different types of questions. Summation n cube plus 1 to the power 1 by 3 minus n. The question is like this. So how can you tell me how to do this one? Here n is equal to n cube plus 1 to the power 1 by 3 minus n, and here take n cube common. If you take n cube common, n cube to the power 1 by 3, it will become n outside. I am taking n. So 1 plus 1 by n cube to the power 1 by 3 minus n. So take n common overall. 1 plus 1 by n cube to the power 1 by 3 minus 1. Then apply binomial theorem for this one. So it will become 1 plus 1 by 3 into 1 by n cube plus 1 by 3 into 1 by 3 minus 1 by factorial 2 into 1 by n cube whole square plus 1 minus 1. So plus 1 minus 1 will cancel out. Remain 1 by 3 n cube. It will become this one 1 by 3. This is 1 minus 2. 1 minus 3 is minus 2. So minus 2 by 3 into 1 by factorial 2. So 2 to cancel out. So 1 by 9 minus 1 by 9. Okay. Into the 6 plus 1. Clear. So take 3n cube outside, or you may take only n cube outside. It will become 1 by n square. It is 1 by 3 minus 1 by 9. I am taking n cube. So it will be n to the power 3 plus 1. Now the term which is outside the bracket, that means the common term, should be taken as Bn. Clear? In this type of the problem of this type, first simplify using binomial theorem, and the term which is taken outside, that means the common term, you should take Bn. So here Bn is equal to 1 by n square. So therefore limit n tends to infinity, an by bn modulus is equal to how much? See here, an by bn, bn is 1 by n square, 1 by n square, 1 by cancel out, and if I take the limit, so it will become 1 by 3, which is a finite positive value. So both will behave alike. That means summation n and summation bn will behave alike. Clear? But 1 by n square, p is greater than 1. So it is convergent. So since summation bn is convergent, so summation n is also convergent. Clear? Another case here. N is equal to 1 minus n into log 2n plus 1 by 2n minus 1. Clear? So your formula, see here, your formula for, I am giving one formula, log of 1 plus x minus log 1 minus x. You formula 2 into x plus x cube by 3 plus x to the power 5 by 5 plus 1. So this is the formula, log 1 plus x minus 1 minus x. Okay, here it will become 1 minus n into, I have told you log of 1 plus x minus log of 1 minus x. So this term must be 1. So divide 2n in the numerator and denominator. It will become 1 plus 1 by 2n and 1 minus 1 by 2n. You can write like this. So it is 1 minus n into, it will become log, put a bracket here, log a by b, log a minus log b, log 1 plus 1 by 2n minus log 1 minus 1 by 2n. Clear? So 1 minus n log 1 plus x minus log 1 minus x. Log 1 plus x minus log 1 minus x. So 2 is taken common. So I am writing 2 here. Okay. So write x. Here x is 1 by 2n plus 1 by 3 into cube of this one. That means 1 by 8 n cube plus so on. Okay. Another term I am writing. Then I will skip 1 by 5 into x to the power 5. X to the power 5. That means 2 to the power 5 into n to the power 5 plus so on. So simply multiply 2n. 2 into n cancel out, it will become 1 minus 1 by 3. N will cancel out. Clear? So all it will become in another quick form I am writing 2n 1 by 3 into 1 by 8 n cube plus 1 by 5 into 1 by 2 to the 5 n to the 5 plus 1. Minus 1 plus 1 will cancel out and take n common and write the 2 inside the bracket. It will become minus 1 by n square. So 2 by 3 into 1 by 8 plus 2 by 5 into 1 by 2 to the 5 n square plus 1. So you should take Bn as this term. Clear? So let Bn is equal to 1 by n square. So therefore An limit n tends to infinity, An by Bn cardinality or modulus. It will be better if you say. So An by Bn, 1 by n square cancel out and I have taken modulus, so it will become plus. So answer will be this one. Because these terms will be 0. 1 by infinity, 1 by infinity, 1 by infinity, all these terms will become 0. So 2 by 3. Directly I am writing the answer. 2 by 3 into 1 by 8, which is a positive finite value. So according to your limit form of convergence, comparison test, both will behave alike. And since this quantity is convergent by p test, because p is greater than 1, here p is 2. So by conversion by p test, summation Bn is convergent. So by limit form of comparison test, summation n is also convergent. Clear? You should remember all the formulas. That means here I have told you log of 1 plus x minus log of 1 minus x. You should remember all these formulas. Otherwise you cannot do these problems. Okay. Without remembering the formulas, you cannot do anything. So you should remember. See here, another question. N is equal to n plus 1 root over minus n minus 1 root over divided by n. So how to do these types of questions? Multiply the conjugate of this one in the numerator and denominator. So that it will become n by a minus b into a plus b. That means n plus 1 minus n minus 1 divided by n into n plus 1 root over plus n minus 1 root over. Put a bracket here. So minus n plus n cancel out, it will become 2 by n into n plus 1 root over plus n minus 1 root over. Here the degree of numerator is 0 and degree of denominator is n to the power 3 by 2. Half plus 1, 3 by 2, n to the power 3 by 2. So 3 by 2 minus 0 is 3 by 2. So let Bn is equal to 1 by n to the power 3 by 2. Clear? Therefore limit, how to find out? See here, limit n tends to infinity, n by Bn mod is equal to limit n tends to infinity. This will go to the numerator 2 n to the power 3 by 2 divided by n into n plus 1 root over plus n minus 1 root over. Clear? So here's coefficient of n to the 3 by 2 is 2 and here the coefficient of 1 plus 1 it will become also 2. So 2 by 2 it is 1, which is a finite positive value. Okay. So therefore both will behave alike. That means summation Bn and summation An will behave alike. Now Here, what is Bn? Summation Bn. By alpha test, here P is 3 by 2 and 3 by 2 is greater than 1. So P is greater than 1. So summation Bn is convergent by P test. So automatically summation N is convergent by limit form of comparison test. If you want to do postgraduate, so you should know these problems. See, another question, N is equal to n plus 1 cube root minus cube root of n. Clear? So, how to simplify this one? That means n plus 1 to the power 1 by 3 minus n to the power 1 by 3. And apply the binomial theorem here. Before applying the binomial theorem, you should write 1 plus 1 by n. Take n common. It will become n to the power 1 by 3. So 1 plus 1 by n to the power 1 by 3 minus n to the power 1 by 3. So take n to the power 1 by 3 common. So it will become 1 plus 1 by n, 1 plus 1 by n cube root minus 1. So n to the power 1 by 3. Expand this one. 1 plus 1 by 3 into 1 by n plus 1 by 3 into 1 by 3 minus 1. 1 by 3 into 1 by 3 minus 1 by factorial 2 into 1 by n square. Then plus 1. Then it will become minus 1. So plus and minus 1 cancel out. N to the power 1 by 3. It is 1 by 3n plus it will become minus 2 by 9 into 2. 2 will cancel out. So it will become 1 by 9 n square plus 1. So take on n common. So it will be n to the power 1 by 3 divided by n. That means 1 minus 1 by n, 3. It will become 2 by 3. 3 minus 1, it is 2 by 3. So 1 by n to the power 2 by 3. I am taking n common. So it will become 1 by 3 minus 1 by 9n plus 1. So this should be taken as Bn. So let Bn is equal to 1 by n to the power 2 by 3. So therefore limit n tends to infinity. N by Bn mod is equal to how much? Directly I am writing 1 by n to the power 2 by 3, 1 by n to the power 2 cancel out. So remain 1 by 3, which is a finite positive value. So summation Bn and summation Pn, n will behave alike. But this quantity, because the power is 2 by 3 and 2 by 3 is less than 1, and if p is less than 1, this sequence is divergent. So here summation Pn is divergent. So automatically summation n is also divergent by limit form of comparison test. Okay. That means without knowing the p test, you cannot do these problems. Okay. They are interrelated. Here n is equal to n square plus 1 root over minus n. Square root of n square plus 1 minus n. Now simply multiply its conjugate in the numerator and denominator. It will become n square plus 1 minus n square divided by n square plus 1 root over plus n. N square cancel out. 1 by n square plus 1 root over plus n. Here the degree of denominator is 1. Where n square to the power half, it is 1, it is also 1. So degree is 1 and the denominator is 0. So 1 minus 0. 1 minus 0, it is 1. So let Bn is equal to 1 by n. So therefore limit n tends to infinity, an by Bn mod is equal to limit n tends to infinity, n by n square plus 1 root over plus n. So the answer will be 1 by 2. Here the coefficient is 1, here the coefficient will be 1, so 1 plus 1, 2, so 1 by 2. Okay. which is a finite positive value, which is a finite positive value. So both will behave alike. That means summation n and summation bn will behave alike. And but 1 by n, that means p is 1 and p is 1 means it is divergent. So summation bn is divergent by p test. So automatically summation n is also divergent by limit form of convergence test. Okay. Same type of question, this one you will do. N to the 4 plus 1 root over minus n square. Same. N to the 4 plus 1 square root minus n square. It is similar to the previous one. Okay. So that question you should do. This one. Multiply the conjugate of this one in the numerator and denominator. It will become n plus 1 minus n divided n to the p into n plus 1 root over plus root n. Okay. So n cancel out 1 by n to the p into n plus 1 root over plus root n. Okay. Here the degree of denominator is n to the p plus half. This part is degree is half. This one is p n plus half. So let bn is equal to 1 by n to the p plus 1 by 2. Clear? Now limit n tends to infinity n by bn is equal to 1 by 2. I am writing directly because n to the p will cancel out the square root of n divided by this one. It will become, if I divide square root of n in the numerator and denominator, it will become 1 by 2. Okay, which is a finite positive value. So both will behave alike. Summation n and summation bn will behave alike. Now under what condition bn is said to be convergent, under what condition bn is said to be divergent. See here, use that formula. And bn is convergent if p plus 1 by 2 it is greater than 1 and divergent if p plus 1 by 2 is less equal to 1. That means take half to that side. 1 minus half it is half. P is greater than half and implies p is less equal to 1 minus half it is half. That means therefore summation n is convergent if p is greater than half and divergent if p is less equal to half. Clear? So these are the two conditions. Because p is unknown. Since p is unknown, so you should write for both the cases under what condition it is said to be convergent and under what condition it is said to be divergent. Another question now, it is similar to what I have done previously. N is equal to n to the 4 plus 1 fourth root minus n, because same type of question I have done for cube root. Okay, so this question you will do. See here, n is equal to n by n square plus b. Condition is a and b are greater than 0. A and b are positive numbers. Here the degree of numerator is 1 and degree of denominator is 2. So 2 minus 1 is 1. So here bn is equal to 1 by n. So therefore limit n tends to infinity an by bn modulus is equal to limit n tends to infinity n will goes to the numerator n square by am square plus b. Degree is same, so highest power of n square is 1 coefficient, and the coefficient of highest power of n square n is a, so 1 by a, which is a positive value because a is greater than 0, so 1 by a is a positive value. Okay, so both will behave alike. Summation n and summation bn will behave alike. But summation Bn is 1 by n. Summation 1 by n, that means n to the power 1, and for p is equal to 1, it is divergent. So summation Bn is divergent. So by limit form of comparison test, summation n is also divergent. Clear? So here another question, an is equal to 1 by a plus nb. Here a and b are greater than 0. Here the degree of numerator is 0 and degree of denominator is 1. So bn is equal to 1 by n. So therefore limit n tends to infinity, n by bn mod is equal to limit n tends to infinity. So n will go to the numerator, a plus nb. It will be 1 by p, which is a finite positive value. Because same degree and the coefficient of n is 1, here the coefficient of n is b, so 1 by b, which is a finite positive value because b is positive. So both will behave alike. That means summation n and summation bn will behave alike. But summation bn is equal to summation 1 by n, which is divergent by p test. So automatically by a limit form of comparison test, summation n is divergent. See another question, 1 by 1 to the p plus 1 to the minus p plus 1 by 2 to the p plus 2 to the minus p plus so on. So how to do this one? Can you do or not? Here, this is the first term. In the first term, I have written 1, 1. In the second term, it is 2, 2. So, in the nth term, that means n is equal to 1 by n to the p plus n to the minus p. Clear? And if I take the LCM on multiply n to the minus p, the numerator denominator, n to the p, sorry, n to the p. So, it will be n to the 2p plus 1. So, now degree of numerator is p and the degree of denominator is 2p. So, bn is equal to 2p minus p is p, so 1 by n to the power p. So therefore limit n tends to infinity, n by pn mod is equal to limit n tends to infinity, n to the p will go to the numerator, n to the power 2p by n to the power 2p plus 1. So here the degree is same, 2p, 2p, the coefficient of n to the 2p is 1, here the coefficient of n to the 2p is 1. So 1 by 1 is 1, which is a finite positive value. So both will behave alike, summation n and summation bn, but summation bn is convergent if p is greater than 1 and divergent if p is less than 1. So similarly summation an is convergent if p is greater than 1 and divergent if p is less than 1. Clear? So is that clear to you or not? Hello? See here, for PG entrance, those who are preparing for PG entrance, you should do the first order differential equation. differential equation means exact differential equation, integrating factor, linear and Bernoulli's. And from second order differential equation also you will face questions, one or two questions. And you should see also Laplace transformations. Okay. And then from area, length, volume you will face questions. And simple integrations, that means normally plus 2 level. Okay. And very important part is from differential equation you will get 2 to 3 questions. And from multivariate questions also you will get 2 to 3 questions. And from probability you will get 2 to 3 questions also. And after that you will face the question from real analysis and model algebra, linear algebra and ring theory. And from this theoretical portion, that is algebra, modern algebra, linear algebra and ring theory. You should remember all these theorems, all the conditions, only statements of the theorems, so that you can answer. Okay. I will tell you I will take the class on double integration, triple integration. Okay. On multiple integral, I will take the live class. So that you will face 2 to 3 questions from double integration and triple integration. That means application of Gauss theorem, Green's theorem, and Stokes theorem also. And before that, you should be thorough with the vector calculus. I have given the complete syllabus in the YouTube, so you can check it out. Okay. And from vector calculus you will get 2 to 3 questions, 100% sure. And that will be direct questions. And I have given one single page in the material, the last page which I have given, and from that page you will get directly 2 to 3 questions. Okay. And I'll tell you the next class when I will take, and one class I will take, another class then I will take the multivariate, that means on multiple integral. Okay. So thank you all of you. So good night, and wait for my next class. Okay. Tipo.